Hi, my name is Erika Wagner, and I am one of the payload sales directors at Blue Origin. Essentially, that means I sell rockets for a living, or rides to space, maybe more accurate. I thought I would tell you a little bit about my history and where my journey has gone, and then answer some of the questions that y'all posted here on higher orbits. So I have been a space fan since I was a little kid. My parents bought me a telescope when I was in kindergarten, a real simple one for going out and looking at the moon. But it was only because I was already excited about the things that I was seeing in space, about the possibilities of going to space someday and of helping others go to space. I got a chance to go to Space Camp and Space Academy down at the U.S. Space and Rocket Center in Huntsville, Alabama, a couple of times when I was growing up. And it was so exciting to find other people who were just as excited as I was about these possibilities and being part of this journey. When I got to college, I decided that I was going to study engineering. I loved science, but more than science itself, I loved the way that science could be used to help solve problems and help people. So my undergraduate degree at Vanderbilt University in Nashville, Tennessee, was in biomedical engineering. I was trying to figure out how do we use science and math and technology to help keep people healthy. And in the course of studying that, I got a chance to sort of reconnect with my passion for space and started looking at the intersection between biomedical and space. So by the time I got to graduate school, I was in a field that we call bioastronautics, and that was how do we keep people healthy on the way to the moon and Mars and other destinations in space. So we were looking at the ways that we understand the human body, the effects that are happening when we put the human body in different conditions of gravity and other environments related to spaceflight. Specifically, I studied how people adapted to centrifuges as a possible countermeasure or way of dealing with changes in gravity. And I looked at the changes in bone and muscle structure that we could expect to see when we go to the surface of the moon and Mars, in what we call partial gravity, gravity that's between the 0G of space and the 1G of Earth. Turns out that we have a sort of use it or lose it phenomenon with all of our body systems. You really, if you imagine yourself laying in bed all day, that's kind of what it's like to be on the space station in some ways. You're not using those muscles, you're not using those bones, your heart's not working as hard. So we were looking for ways to keep people healthy as they were experiencing those conditions. When I got out of school, I had a chance to go work for the X Prize Foundation. And the X Prize gives big multi-million-dollar prizes for solving some of humanity's greatest challenges. And I got a chance to work on everything ranging from space to deep sea technologies to autonomous vehicles, global health, brain-computer interfaces, really starting to think about how do we inspire the world to go off and solve big problems. And that really gave me a passion for solving not just the big technical problems, but these problems that live at the intersections. I sort of consider myself a translator these days, because I speak a little bit of science and some engineering and a little bit of policy and a little bit of business. And it turns out when you put all those things together, that's where a lot of the big things in the world get done, a lot of where the decisions get made on how we can go and do bigger things and more exciting things. So I live now at the intersection of those fields. I help people imagine the futures of space and send payloads up on spaceships. And what I love most about doing that is this idea that space is opening up much, much wider than it used to be. Right? It used to be that you had to be part of a national government, a national space program, or a very, very big corporation to send something to space. And now those doors to space are opening wider and wider. So not only can a family send something to space, but so can a school and a classroom, a club, a group of friends. And one of these days, it's going to be sending ourselves. We're going to be opening those doors so that more and more people earn their astronaut wings and travel above that Kármán line that marks the boundary between the atmosphere and space. So I'm excited about opening space for new users and new uses and figuring out how do we do that in increasingly broad ways as we democratize space access. So y'all asked a few questions. I figured I would dig into those. The first question I got was, what is the hardest thing about our next trip to the moon? In so many ways, I think it really is that intersection. A lot of this technology has been developed or is being evolved from the things that we were able to do in Apollo and the space shuttle and the space station. But what we're doing now is thinking about putting that together in new ways and doing it sustainably, not just going once and putting flags and footprints on the moon, but going back and this time to stay. So I think how do we bring together the political will, the economic engines, the excitement, the technology, the passion, the feasibility to do this in a way that lasts for a really long time? The next question was about Mars and going back or going forward to Mars and really setting up the first Mars bases. The question that was formulated was, is it a good idea to invest in bases on Mars? I think that depends on who's making the investment. Our governments are really good at making investments in things that are risky and challenging and don't necessarily make a profit right away. So for the government, I think travel to Mars is a good future destination. Is it a good economic decision? Is it a good business decision? I think that's a harder one to answer. I certainly hope that someday that we have strong businesses on the surface of Mars. I don't know that we're there in my lifetime. Questions about terraforming and growing food on the moon and Mars. So terraforming means turning another planet into a planet like Earth, giving it an atmosphere and pressure and things that we can breathe and grow in. I think that is a long-term ordeal. Very, very hard on the moon. Possible but very difficult on Mars. But the idea that we could set up greenhouses on the moon, greenhouses on Mars, and use that to grow some of our food is really compelling. We know from studies on the space station that growing food is not just about the calories that we're getting or the nutrients that we're getting, but it also is a very human thing. It's part of what connects astronauts to their living and working in space. And so I think that it's definitely a great idea for us to grow some of our own food and some of our own flowers and some of our own photosynthesizing plants that are making oxygen for us. And whether that is the primary design of the system or just the benefits that we get from having lovely things around us, I think that both of those are worthwhile. I was asked as a foodie, if I got a chance to go to space, what food would I miss the most? Oh gosh, that's a hard one. I would definitely miss chocolate. I love a good dark chocolate. I think I would also miss the variety. I love to eat and cook as a form of exploration, foods from different countries and different cultures. And so in a lot of the trips to, say, the space station right now, the food selection is somewhat more limited because you're planning for those sort of logistical details. So I would miss the ability to decide that night that I wanted to have Thai food and have the ingredients from the grocery store. But I think you can still be pretty creative on a space journey. An interesting technical question that was asked. Why do rockets throttle up slowly rather than going to 100% thrust when they're sitting on the launch pad? That's a fun one because it brings together a few different things. One is the engine itself. So are you using a solid rocket motor or a liquid rocket engine? So solid rocket motors, like you might find in a smaller Estes rocket or the solid rocket boosters on the sides of some of our much larger rockets, can start faster. They are often patterning on the inside of the fuel so that they start that burn a little bit more gently. You don't want to hit the throttle too hard or you're going to shake and rattle and roll everything. Your accelerations get much higher. Your loads on your engine and your rocket get a lot higher. So if you have ever sat in a car seat with a driver who's really aggressive on the accelerator, you may have felt that push of the G back into your seat and the jolt of the car. So rockets are the same thing. We want to be gentle with the hardware that's inside, the people who are riding on top. So that's why we throttle up and get into those throttling modes. Now, throttling is a lot easier in many ways with liquid rocket engines because you can throttle up and throttle back. You have a chance to really sort of control the amount of thrust coming out of a liquid rocket engine much more than you do with a solid rocket motor, where that's really sort of designed into the way that the propellant is encased. Question here about favorite memories of space camp. So I had a chance when I was a teenager to go to the upper level Space Academy. And in that Space Academy, we were simulating a mission to a space station and starting to think about the kinds of research that might be done on space station. And the research that our team got a chance to do was a gel electrophoresis. So we were taking protein molecules and using an electric current to spread them through a gel and watch and see how they traveled on the base of their charge and their mass. And it's a very basic technology these days in biomedical experimentation and biological labs. But at the time, it was a very new idea for how you would use it in space and how we would use space as a tool for making new medicines and studying the effects of gravity on biology. So it was really neat at that sort of formative stage of how that science was coming together to be able to do it on the ground and to envision what it would be like to use space as a laboratory. So that's definitely something I remember from my time at Space Camp. I think that was all the questions I got. Michelle, Higher Orbits team, thank you so much for what you do. This opportunities are so huge for the next generation just to dream bigger and be a part of what space is and have space as a part of their day-to-day lives. And I hope you'll all come and join us. Thanks so much.